Right. Okay. The object-oriented concepts is very, very useful. Uh, Now, so far in our discussion to structure our data, we use functions, right? And we discuss the functions are block of code, which we can use to name a block of code. And then this name set can be used to simplify our program. So that's one way to handle it. The object-oriented programming or OOP is another paradigm, the different way of represent the same. So when it comes to object orientation, we use the basic concepts called classes and objects, right? Now, for example, classes are like templates, and the objects are like the instances. For example, let me take you as a example. So each students in the class I can represent um, as a objects. So each individual I can represent as set of objects. Then we have common things like, let's say we want to keep, let's say, information such as your name, registration numbers, your contact details, and so on. We call data, right? So if you are going to have a template, which what we are going to say, we can keep it as a class. So it's a class, it's like a template, like before you building your home, you can have the plan. So something similar to that. Right. And these classes we can use to represent anything in the outside world. For example, let's say if you want to have a information system, let's say on student management, I can create classes for students, I can create classes for lecturers, I can create classes for courses and so on. So whatever we want to represent, whatever the things, we can create classes, the templates. And the real ones we can create as instances we call objects, right? So therefore, when we talk about the classes, we normally talk about variables. That means the data items that we want to keep. Things like if you take student class, we can have things like your name, registration number. They are called instance variables. Then you perform different things like you study, you sit for the exam. These are called methods, whatever that you can perform, right? So those are the basic ideas we have. And then the object interaction happen through the messages, which I will come. So we can have some message pass among these objects. Okay, so those are the key concepts. Now, the next thing is when we design class, there are graphical representation. Like in algorithms, we use flowcharts. Like in classes, we have this simple representation where you use like box like this. So box representation like this. And then we have a class name. And then we have set of data items and then whatever the methods. So in this example, I'm actually representing a credit card. In a credit card, we know we want to keep track of customer name, bank name, account details, credit card limit, credit card balance. So those are the information that I want to keep with the credit cards. So those are the ones actually we call instance variables. Then we can have set of methods. These methods can be used to, work with the credit cards. For example, you can have methods for what we call getting information about the customer, bank, and balance. And then you can make purchases, and then you can settle the due amount using, make payment. So these are like set of methods that actually we can define to work with credit cards. So that's graphical representation. Similar to that, you will see there are other examples like in a person, we can have instance variables like name, address, age. We can define method like walking, talking, breathing, running, whatever that we want to represent as methods. Take an email. email the data items that we want to store, things like recipient list, the subject, the body, and then the methods like adding an attachment could be a method. A sending is a method. Take a car, for example, we can keep track of year, model, mileage, and then the methods like accelerated brake can be used. Okay, right. Now let's see the process of class to objects. Now I hope you understood the basic idea of classes. We see the structure, and that's kind of a template I told you. Here we it says it's a pattern. Whereas we can create actual cars based on this template, we call objects, right? The process of generating these objects we call constructing it. We use a constructor to create our actual set of cars, and it will be different. You can see that some of the colors we use to say that the objects are different. It's similar to the student class that I have explained earlier, and for each individual you have your own set of values and you are different, something like that. Okay, so that's about the process, right? Going back to in Python. So Python, we have uh, a keyword class to define the classes. And then there's a special keyword that I would like to discuss, which is called self keyword. So no, this self keyword actually plays a key role in object orientation, because we know that classes can be used to create objects, and then sometimes you have to refer the same instances, right? When you want to specify the same instance, we can use the self. When you say self, you are going to work with the same object, which means that sometimes you can have methods where you work with other objects. So therefore, self, which means that you identifies the same instances, right? We call own instances we can use. Right, I think we are good to go. So let me start with a small example and let me explain how it works. So in this particular example, I'm going to use a student class. So you can see in the left-hand side, we have a template. And this is very, very simple one that I would like to discuss. Therefore, I use only a one variable and two methods actually, right? Although there's a line in between, ideally it should be, three parts. I have a one variable and then we have two methods, right? Okay, so let me explain this with the Python. I'm going to share my slide and then we'll go one at a time. Right, so let me go back to hope you can see my screen. So what I did, I have a new window. I'm going to create a file. Right. So simple one, I'm going to create a class student and I can just say pass. I mean, like this is just the very basic structure for creating a class. So we create a class of students and we have nothing inside. That's why we have pass here. Let me save it. Right. So this is very simple one that we have created and saved as program number 18. And that's it. I mean, you can run it nothing is there because we have nothing written inside, right? But you can see it works without any errors. So let me populate uh, the student class. Right. The first thing that I'm going to do, remember we had a variable name. So we have to define how we actually use name. So in this particular case, the very first thing is we are going to have the constructor we say in other programming languages. So there will be a method that you normally see in any of the classes. This is called init method. So init method, we will have def, and we will usually start with the two underscores. Note that there are two underscores, underscore, underscore, then init, underscore, underscore, and we will start with self keyword. Now, when we say self, I told you, you work on the same objects, right? And then this is the next one we could have. So if you run it again, we have nothing defined inside this, right? Now let's assume that we want to create student objects by providing student name. So that means this constructor we have to provide, other than the self, the student name. I will say it's student name. And then whatever we get, this is going to store in the class variable is name. So when you refer your own instances of, let's say, instance variables, we use self keyword. Usually we say self.name, and then we say student name. So the idea is whatever the name that we will get, we will put on to the name instance variable, right? This is enough, and actually we can use this to explain a little bit more on how it works. So now, since we have to provide the student name, right? You can create, let's say I'm going to create a student object. Let's say it's S1. I can say something like this, student. And then I will provide whatever the value that we need. In this particular case, we have to provide some name. So we'll say summer. So which will create an object. So if you say S1, it's an object, student object. You notice here it says student object. And if you want to, get the information, for example, you can use a dot operator, and we'll say name. So what it means, we are going to access student objects. Within that, we are going to access the student instance variable. And it's summer. Remember, we take the summer, we store in the name. So that's why you can actually access it. Right. Now, generally, we don't recommend direct access of variables like this. So therefore, usually, we will have what we call getters, or meaning like some get method to when you need to get a name, something similar to this. So for example, let me define another method. So this time I'm going to say get name, and then we'll say self, and we will say return self. So this is the recommend way to use it. So the idea is I'm going to do the same thing. I'm going to create the student S1, but this time I'm going to say whatever the method. So I'm not going to directly access, attributes or instance variables. I can use method. What is the method? It says get name. So when you say get name, this is what is recommended, and you will get an outcome like this. So this is very, very important. And many of the times, most of the things that you will see is implemented like in this fashion. You create an instance or object, and then using the methods attached to object, you can access in there. For example, I hope you remember the list methods, right? So you can use in the very similar way, right? Now, if you go back to my example, I had another method we call study, right? So let me, you know, put this as well. So we have def. Let me say study. In this case, again, I'm going to prefer the same object. And then simply I will return a message saying study. Right. Now, if I run this, and then I have to create the same thing. So now we have both get name and s1 dot study. And this is the outcome. Actually, you can create any number of objects using the same fashion. So for example, let's say I'm going to create another object, let's say S2. So let me say it's student Paman, right? And now you can say S2 get name, and then S2 dot study. Okay, you got the point. Right. Any questions on this? We can discuss in detail about how OP is implemented. There are other core ideas are also there in object orientation, although I discuss only the classes and the objects, right? There are things like what we call the encapsulations, inheritance, polymorphism. These are like key ideas, very important in object orientation, which I'm not going to discuss in your level. But let me at least discuss. Remember about, I hope you remember about the use of list class. So list is object of built-in list class in Python. So let me explain why I have discussed the basic OP with you. So for example, we know that when you want to create a list object like we use here, right? It's slightly different, but for example, let's say I can say, okay, my list, I can create, items like this, which is a class. So for example, if you say type my list, and you say class list, similar to that, if you say type S1, right? It says class student, right? So you see the similarity of use of that. So the methods that we have discussed, for example, list, we can append, right? Hope you remember. So when you say print my list, we had 1, 2, 3, 4. So for example, my list dot append. So this is similar to when we say S1 dot get me. Only thing is we are appending. Whatever you append, you give it as a uh, argument here. So let me put append 5. And then if you print the list, actually list is manipulated. So I hope now you have understood why we need to understand the object-oriented concepts. So if you refer my note, I have more details about the implementing credit card class, which I'm not going to discuss in detail. The idea is at your level, I don't think we need to know more about how the object orientation works, but I think the basic is enough, right? So therefore, so I'll switch to my next topic, right? So let me move on to NumPy, which is efficient way of handling, matrices, the actually numerical computing part. So let's start our discussion. Okay, now First part, I'm going to discuss how matrices are defined in NumPy library, and then how you manipulate them. And then we start with the vectors, vector creations, then matrices, and then matrix creations. And then we can talk about the matrix manipulations. So I hope you are clear with it. Okay, one way is you can think this as a kind of a list, but the data structure it uses, they define a class called ND arrays. And when you're handling large arrays or matrices, especially when you're manipulating, so NumPy arrays and dimensional arrays are much more efficient than the lists. So while lists are very useful whenever you want to represent arrays or vectors, especially when you are working on large ones, you should define them as NumPy arrays. Okay, so let's start discussing this. Maybe I will switch to my into shell. So the first thing that I would like to discuss is a simple list. So let me create a list as test1. So let me say test1, and let me say I have 3 items. And we know that when you say type test1, okay, it's a list. In NumPy, we have to first import it. We'll say NumPy as NP. And once you import that, you can use the methods. We can say NP array method. And within the array, you can define as a list. So 1, 2, 3. So the test2, if you check the type of test2, now you have defined this as NumPy n-dimensional array. So make a note of this, how you represent something as a built-in list class, or if you're using numerical Python, how you define them as n-dimensional array. So that's the first thing that you need to understand. And the second thing is, as I told you, it will be much more efficient. Right. Next. So let me explain how we may create one-dimensional arrays, or we can call vectors. Right. So to explain that, I will create a vector A. So I'm going to create a simple, I can say this is as a row vector. So I will say NP array, and then I will have list of numbers. Right, I have 1, 2, 4, and 5. So when you print A, you don't see any difference. But notice that the comma is not visible here, but simply it's a n-dimensional array we have used. And we should use type A, you will see we have defined as a NumPy n-dimensional array. So when you define anything as an NumPy n-dimensional array, you will get information. Like, for example, if you want to get the length of the vector, there's a command called shape. So I can say a.shape, which will give you as like you have 4 elements. Then you have something called size, which says, number of elements. We have 4. Right. So that's the idea. And the next one is, if you want to access individual element, you can use the index. Like in the list where I have the, for example, if you want to access the first item, I can say, okay, print a node, which is I'm accessing the first element. Right? That's one. Okay. So I hope now you understood how we can actually create one-dimensional arrays. Let me go back to my note as well. right? So you can see how we actually define it as NumPy arrays. So that's about the row vectors. Let me explain how to define column vectors. Now, row vectors, we just separate commas. If you have a column vector, each row we are used as lists. So therefore, same thing if you represent as a column vector, we have to use lists. So in here we have one element, and then this will define as a column vector. Let me explain with the shell. So I'm going back. For example, I will say b equals np.array. And you can notice that we define it as a list of lists. And each list we have one item because it's a column vector like this. Now, if you print b, usually you notice that this is not possible with the list data structure, built-in data structure. It will not display like this. But when you define it as a NumPy array, it will display as a column vector, right? And the next thing is you can use the same things that we have discussed. If you say B shape, it says 4 rows and 1 columns, and B size, it says, okay, we have 4 elements. That's how we can, create a column vector and a row vector, right? Then there are methods available for you to generate vectors. Again, very, very important this part, because when you work with the data, generating vector is very, very important. I hope you remember the range function we have used. Likewise, we have a range, array range, which we can use to generate an array, right? So array, it's similar to range function as well. Okay, for example, let's say if you use np dot arrange, you remember a range function. Similar to that, you can go up to 3 values: start, stop, and the step. So for example, if you want to get values between 1 to 10, then we say 1 comma 11. 1 is a starting value, 11 is the stop, right? And it will generate array of numbers from 1 to 10, right? Similar to that, if you use, let's say, odd numbers, I can say 1 comma 11 comma 2, which will give you, sorry, I made a mistake in the spellings. So in this particular case, we printed only the odd numbers between 1 to 10. Yes. Starting value should be 2, end value is 11, and the step is 2. Okay, Sachit also got it correct. Yes, good. Which will get even numbers. Okay, good. Another question. What about going from numbers 10 to 1? Three values. What is the starting value? So let's say we want to print numbers from 10 to 1. Starting value is 10. End value will be 0 because we want to get from 10 to 1, right? Step. Of course, we have to have -1. It should be negative. Okay, so those is a range function. If you want to get a set of numbers, again, this is very, very important in some case when you want to generate sequence of numbers. Like in graphics, I will explain how you can use this to draw graphs. Right. The second function I would like to discuss is called linspace, right? For example, anything that you want to know, you can use help. For example, I can say np range should give us how to use range function. It will show you like how exactly it uses. The help will give you examples as well. So remember, you can use help. Second one we call linspace. Linspace means we are getting linear space vector. For example, if I say np dot linspace, the linear spaces, let's say 1, 100. So what this gives you is you get a set of values between 1 to 100. Notice in the array, the first value is 1, the last value is 100. Right? So let me put this as y. We can say np.linspace. I will say 1, 100. And notice that in this particular method, it will include both the numbers. So when you say print y, you will get the values. And for example, if you say y dot shape will give you the number of elements. You have 50 elements. Okay, so what happens in this method? The linspace will have two values, start and end, start and stop. It includes both start and stop, and then it will generate 50 elements. Of course, you can change this. For example, if you need 100 elements, this is how you should use. So for example, I can say we use y equals np.linspace. I could say 1, 100, let's say 100. So the idea of this is what this means, we saying that, okay, I need 100 elements between 1 and 100. So of course, if you print y now, you notice that we have 100 elements. So you can see print shape, y dot shape or y dot size will give you the number. We have 100 here now. Notice that you have decimal point, which means that all these numbers are floating point numbers, float values. What do you mean by that? If you use a linspace, it will generate, in this particular case, 100 elements between 1 and 100, but they are as, floating point value. If you want to change, right? If you want to change, it's easy. Let me explain that one as well. For example, if you need a set of int value, you can say that we can have another value and we say d type. And we'll say int. The meaning of this is we will say, okay, we need y, but we need y as a integer value. Now you notice, if you compare my previous answer and the answer now, previously, the default data type was floating point values or floating point numbers. Now we generate as an integer value. Right, good. Okay, so now I think we discuss about how we may actually generate, vectors. Okay, now I would like to switch my discussion to matrices. So let me start with my slide. So if you go back to my matrix generation, again, it's similar to the ideas that we discussed earlier. The matrices are defined as list of list. We call nested list. And for each row, we will have a list. So in this particular example, we will create a 3 by 3 matrix A. So you can notice here A. In the first row, we have 1, 2, 3. The second row, we have 4, minus 5, 6. And third row, we have 5, minus 6, and 7. Right? Which will generate a 3 by 3 matrix. Okay, let me demonstrate with the shell. Okay, so the first thing that we are going to do is we create a matrix, and we are using NumPy array. And then we create a list of lists. So the first one, you notice that we have three items. The first list, that means the first row. Second row, we have 4 minus 5 and 6. Third row, we have 5 minus 6 and 7. Right? And when you say print A, you will notice that we'll get a metric shape 3 by 3. Actually, you can look at the shape. So when you look at print A dot shape, it will say it's 3 by 3 matrix. Okay, so now that we have discussed about the matrix, so let me discuss how to access element. Now, for example, you can use index. For example, if you say print A naught, it will actually gives you a first row, right? And then if you want to say first row, first element, we can say 0, 0. So idea here is we have a 3 by 3 matrix, and we can use index to access rows. When you say A naught, we get the first row. A naught, and again within that, if you say a naught, that means we access the first element. Actually, there's a shortcut as well, which we will discuss in detail later on as well. For example, you can say 0, 0, which gives you the same idea, right? It's the same, right? Can you tell me, like, if I want to access the middle element, what should be the command? Okay, let me again explain what I want to do. So in this particular example, right, we have a vector of 3 by 3. We have 1, 2, 3, and then 4 minus 5, and then we have 6, then 5 minus 6 and 7. So this was a matrix. And we know we are using indexes. So if you go row by row, if you want to access the first row, we use index 0. Second row, we have to use 1. The third row, index is 2. Similar to that, if you want to access columns, you can use to access the first column, we have to use index 0, then 1, then 2. So when I say a note, what happens? It will access the first row, right? But when I say a node, so it will first access this one, and then it will access the first element. My question was how to access the middle element, right? What is middle element? This element. So how can I do that? That was a question, right? Now for this one, what I need to do is, right, first I have to select second row, right? So how do you access the second row? How do you access the second row? We can say, okay, print. If you want to use second row, I have to use index 1, right? And then I have to access second element. So if you take this one, and if you want to the second element, again, the index is 1. So one way we can use this, or you can use the shorter version. We can say, okay, A 1, 1. So make a note of accessing, each individual ones is very, very important. And there are various ways that actually you can do that. Since I have explained use of a naught node, we can use this, and also the slicing idea that we have discussed from the string. Now, for example, one way to handle this is, let's say, right? So we discuss each individual elements, right? So for example, if you want to access the first column, you can use this notation. I hope you remember this one. The colon, if you use it, colon specified everything. And then I can say 0. The second one is the column. Sorry, I forgot to put the bracket, which you will get 145, which is the first column, right? First column. Similar to that, if you want to access the first two columns, I can put 0 and 1. Sorry, 0 and 2, right? And then I also discussed that if you have a situation, you don't need this. You can refer back what we have discussed last time. So what this means, we access the first one is rows, the second one is a column. So I will say what I want this. For example, if I want, let's say, first and then the third, I can use like this. Okay. So these are the ideas that we use from the previous one. So make sure that you understand everything. Now this is about the column manipulations. So something similar to done for rows as well. For example, let's say I need the first two rows. So I can put like this. First two rows. And then let's say I need first and the third rows, then I can say 0, 2, colon, which gives you the, sorry, I made a mistake. What was the mess? Okay. Okay, I forgot to put here. Okay, so if you put it like this, right? First and the third row, right? So make a note of this as well. Again, in this manner, then you can, access anything the way you want, right? So make a note of this. Right. So that's about the matrices. So we discuss about how to create a matrix in NumPy. Let's go back to the note again. So in this example, we discussed how to generate matrix A, and then also we discussed various ways of accessing elements, right? Okay. Next, the next part, I am going to discuss how to generate matrices. There are various methods we can use to generate matrices. I have listed some of them, and then I'm going to explain them. The first one, we can use method ones to generate a matrix which fills with ones. Zeros we can use to fill a matrix with zeros. Third one, I can be used to create matrix to generate identity matrices where you have ones in the diagonal and zeros in the off diagonal. Then there are various methods we can use to generate random matrices. Generating random matrix also very important. Okay, let's go back and let's discuss how we can implement them. So I'll switch back to the shell. Right. Going back again, this set of methods can be used to again generate vectors as well. So let me start with the vectors and then the matrices. So if you say np dot ones, and if you just provide one single value, this will create a, a vector which fills with ones. Again, notice that this will be represent as floating point values. Similar to that, if you provide two values like this, ones, let's say 3 comma 1, remember that it's enclosed. If you put it in this way, this will generate a column vector. We say 3 rows and 1 column. So this will generate a column vector. Right? So if you need a matrix, now you know what to do. Right? For example, let's say I want to create a 3 by 3 matrix. So I will put 3 by 3 like this. So as you can see, ones which will fill vectors and arrays with ones, right? And we have to provide, if you put a single value, it will be a row vector. Column vector, you have to provide two values, number of rows and the number of columns. Okay. And if you want to change the data type that we have discussed early, so for example, let me take this one. You use data type, D type, and you specify the data type you want. For example, if you want to fill as integer values, you can say D type equals int. Right. Going back to zeros, it will be the same. So for example, if you want to use, let's say, zeros, it's the same as the previous one, right? If you need a column, then you have to provide two values. So we will say 3 comma 1, that means 3 rows and 1 columns, right? And then if you need like 3 by 3 matrix, then you can use like this. So we discuss ones and the zeros. Identity matrix, very similar, but then you can, it's usually symmetric. Therefore, you can say np.I, you can just say 3 to provide you 3 by 3 identity matrix. Make a note of this. Okay, so now that we have discussed generation of vectors and matrices, with that, let me explain how to generate random matrices. So there's a random the library, we can use it here. So in NP we have something called random. So you can use np.random, and then you can use, there are a couple of functions. The first one is rand. So if you just put rand, you get a uniform distributed values between 0 and 1, like when you say rand5. Similar to that, if you use the same function and if you provide two values like 3 by 3, you will get 3 by 3 random matrix. Again, make a note of this. The values will be uniformly distributed between 0 and 1. Right. So that's about the random matrices using rand function. If you want to use normal distribution, there's another function very similar to this, but it uses what we call rand in. So if you use rand in here, again, it's normal distributed values, right? It goes from -1 to +1, right? and use the function rand in. So if you need like 3 by 3, use rand in 3 by 3, which will give you values like this. Right. Okay. So the next one, if you want to use integer values, we have rand int. So for example, if you say np dot random dot rand int, and let's say you need a number between 1 to 100, you see 1 comma 100. So rand int will give you a number between 1 to 100. So every time when you run it, you get different values, a number between 1 to 100. Okay. So let's say you need 10 numbers. Provide the third argument. So let's say I need 10, then I put 10. So every time when you run it, it will give you 10 random numbers between 1 to 100. Right. If you need a matrix, take the same thing. Instead of just one value, provide two values as a tuple like this. You will get 3 by 3 random matrix, which fills numbers between 1 to 100. Okay, so now we discuss a couple of ideas where we can use, random values. We use rand function, uniform distribution, rand n, normal distribution, rand int, random integer values. Remember when I use rand in, I said we are using, you get values, random values from a normal distribution. One correction, when I said it's between -1 and +1, remember in practical use, there could be a couple of ranges. So usually the property is the mean will be 0 and standard deviation will be 1. So therefore, depending on what values you have, the range will be different, right? So for example, it might also go from -1 to +1 or -2 to +2 or even -3 to +3. But it will be very rare. Commonly, it will be between -1 to +1. For example, 95% of the time, it will be between -2 to +2. 99.7, it will be -3 to +3. So that's a small correction of what I have discussed about the random function, right? So make a note of this. Any questions on generating vectors? Now let me explain the use of or generating matrices. The one thing that I'm going to explain, you can generate a matrix like this. So let me say, I'm going to create a matrix X. I will use array. And then we know I'm going to use list of lists. So let's say I'm going to do this manually, and then later on I will explain how to automate this. 5, 6, 7, and 8. If I go, you don't see, so therefore I'm going to continue. I will use slash, actually backslash, to say that, okay, I'm going to continue. And then 9, 10, 11, and 12. This is the third row. Then 13, 14, 15, and 16. Right. So this is X. So if you say print X, Yes, we'll get 4 by 4 matrix. Now, remember my previous discussion, we know how to access each individual elements. For example, let's say I want to access something in the third row. We know that third row is the index 2, right? Third row, yes, index 2. And if you need the fourth column, that is index is 3. So the element in the third row, fourth column, that is 12, right? So we have third row, and then the fourth column, the value is 12. So that means if you want to access only the third row, I think we discussed this idea, the colon, which tells us everything from beginning to the end. Similar to that, if you want to get fourth column, you can use colon. Actually, what I discuss this is, let's say I want to discuss a submatrix in the middle, right? So let's say I want to get, you know, the rows in second and third and the columns in second and third, which means a 2 by 2 matrix in the middle, which is 6, 7, 10, and 11. Let's say I want to access it. What is the code? So for example, I will say, I want to say first the index 1 and 2. So that means 1 colon 3, right? And then columns 1 colon 3. So we get the middle value of it, right? So let me say this is y. So I can say y equals x 1 colon 3, which means 1 and 2. Then 1 colon 3, again 1 and 2. So this is, I'm going to say y, right? So if you say print y, we know what will happen. It's in the middle, right? Okay. The next one, I'm going to change y. So I'm going to say, I'm going to take all the elements and I'm going to say 0. So if you say print y, you will say 0. Okay, this part is very, very important. Make a note of this. If you say print x, what do you expect? What do you expect? Do you expect that 1, 2, 3, 4, 5, 6, 7, 8, 4 by 4? Just notice that this is updated. You see, the values in the middle of the matrix is updated when you change value of y. Okay, let me explain why this is happening. So when you say x and when you get y as a submatrix like this will be a view of x. View of x means it's referred to the actual values in x. So if you change values of y, you will notice it will change values of x as well. Because in Python, it refers the same object. Object references are there. Therefore, if you want to take a part of the matrix and if you want to update, for example, you have a data set and you want to change the part of the data set without harming the original, then you should not do like this. Because if you use this fashion, it will actually refer the original one, which is we call view of x. So therefore, if you want to take a part of this, right, and you want to change it independent of the original matrix, okay, let me explain how to do that. So let me start my x again. So this is my x, right? And let me say I want to get the the submatrix, what is in the middle? Remember, I use the first, second and third rows and second and third columns, right? And if you type like this, it will refer the original values. So take a copy of this. Okay, make a note of this, very, very important. And when you say why, you get what is in the middle, but this is the copy that you have received. So it will not refer the actual one. It will not refer the actual one, right? So therefore, if you change this, for example, you can do the same modification, right? And then if you print y, you know the values of y is updated. But if you check x, nothing will happen to x values. Okay, I think we have discussed too many ideas, so I'll stop at this point. The very important idea that we have discussed is when you manipulate, especially, take a part of this, or if you want to manipulate without affecting the original, then you should take a copy of this, right? For example, let's say we have x here, and let's say if you say set equals x, and if you update something to set, it will affect x because it refers to original. So therefore, if you want to do something to set without affecting x, you should take a copy of x. Make a note of this. It's very, very important when you're manipulating the data, right? So with that said, I would like to stop at this point because and then I will send you all the notes for you so that you can practice and come.